Okay, so here it is. What is an IP address? I think already I given an introduction to IP address, but again, so we have to see what is IPv4, IPv6 kind of stuff. Okay, what is a IP address? Is a logical address. We are all using IP address only. Either it is IPv4 or IPv6. Okay, what is an IP address? It is a logical address. It is uniquely identified device in the network. It is not unique address. It is a uniquely identified device in the network. In a network, you have a devices. Every device must have an IP address. Either it is manually configuration or a automatic configuration. It is okay. So it depends upon your network spaces. We will give as an IP addresses. Okay. So we have a difference between IP address and MAC address. So 1 second, I will take this information also, just for your notes purpose. Okay. We are all using TCP/IP type of network only. And we are using star topology. So here it is. There is always a basic question, difference between IP address and MAC address. Okay, IP address is a logical address, MAC address is a physical address. We can change IP address. IP address can be changeable. Okay, and MAC addresses, we cannot change the MAC addresses. In a MAC addresses, there is no public public MAC address, private MAC address is not there. But because of MAC address is on the adapter. On your NIC, we have a MAC address, but IP address is for each NIC we have a MAC IP address, but in communication to the private and public, so we have a public IP addresses, private IP addresses type is also there. In IP addresses, we have two versions, IPv4 and IPv6. In MAC address, we don't have a different versions, only one MAC address. So MAC address size is 48-bit in binary and it represented in 12 hexadecimal numbers. Whereas IPv4 is 32-bit, IPv6 is 128-bit. IPv4 represented in decimal format, IPv6 in hexadecimal format. All communications with IP address only. We cannot send any packets through MAC address. Only MAC address we cannot send, but we can send with the IP address to destination. Like you want to send any packet, so you have to give destination IP address. If you give destination MAC address, then no communication. These are the basic differences. Here in IP addresses, in coming to the IP addresses, we have IP addresses, one small part it is, then it is two versions. So generally we are using IPv4 version only. Okay, IPv4 is 32-bit, IPv6 is 128-bit. Whereas IPv4 is 2 to the power of 32, 4.3 billion IP addresses from IPv4 version, and 3.4 billions of IP addresses, meaning is 3.4 into 10 to the power of 38 IP addresses from IPv6. It means IPv6 size is very bigger compared to IPv4. Okay, and IPv4 we write in the decimal format like this. This is the format of IPv4. It is 4 parts are there. Each part is divided into dots. 4 part means 32-bit by 4. So each part is 8-bit only. So this each part we call it as an octet. Each part we call it as a octet. Okay. Next, this is what it's not a point, it is dots. 192.168.1.101. Okay. And octet means, already I told, it is 8 bits. 2 to the power of 8 is 256. Meaning is each octet size is from 0 to 255. Means 0, 1, 2, 3 up to 255. Means any of octet is more than 255 means it's invalid IP address. Then we can go to this hexadecimal format. Okay, so IP address is written in the hexadecimal format for IPv6. Okay, one hexadecimal size is 4 bits. So totally 32 hexadecimals are there. 32 hexa numbers are there in the IPv6. This 32 are each 4 hexadecimal numbers. The 4 hexadecimals are become one single block. It's totally 8 blocks in the hexadecimal and which is divided by colon. 4 hexadecimals comes under one block. Each block is divided by colon. This IPv6 can be written like a full-fledged like this. Okay, this is also IPv6 address. Meaning is if you put a colon means it filled with the zeros only. Different ways to write a IPv6 address. Okay. Different ways to write a IPv6 addresses. These are the certain examples. There are some examples. Same. This is we can write like this. We can write like this. So IPv4 32-bit, IPv6 128-bit. So coming to the IPv4, IPv4 is divided into 4 parts. Right, as I said, so first part we call it as a first octet, second octet, third octet, fourth octet. It's divided by dot. Okay. Some people for their convenience purpose or for understanding, so each octet they put a names like a W, X, Y, Z for easy to understand. Okay, but first one is called first octet, second one called second octet, or you can use W, X, Y, Z kind of stuff. Already I told each octet, in a octet means 0 to 255 size only. This is the total IPv4 range. So IPv4 IP address starts from 0.0.0.0 and the last IP address is 255.255.255 only. Okay. So how it is there? So first one is 0.0.0.0, then 0.0.1, 0.0.2. It will keep on going on. Okay. So once it is reaches 255 in the this become 255. The next one is 1.0, 1.1, 1.2, 1.255, then 2.0. It keep goes on like that and finally reaches last number is 255.255.255. Okay. I'm telling very faster or very slow.
A little bit, sir, slower.
One more little bit slow. Okay.
Yes, a little.
Okay. Here about in IPv4 we have a local host address. What is this local host address? There is some explanation is also given. I will draw it again. So, guys, already I told if you are in a network and you want to communicate in the network, means your device is a network and you want to communicate in the network. Okay, so they must be physically connected. Means physically means there must be a connectivity, either wired or wireless connectivity is there. Connectivity is there. So then only we can able to communicate. Okay, first one is should be connected. Second one is every device to that their connected NIC must have an IP address. Then only one PC to another PC will communicate. For example, this is A PC want to communicate B PC, so they will communicate with the IP address only. A want to communicate DPC, of course, with the DPC IP address only. For example, I am writing some IP address here. For example, this is 10.0.0.11. So 10.0.0.12. This PC IP address is 10.0.0.13. 10.0.0.14. Okay. So no need to follow a sequence, but we have to follow the network sequence first. So you want to communicate to C, for example. In APC, I put a ping command. For example, I want to send a ping request 10.0.0.13. Then packet will send to the switch to C, and C receive the packet because this is the destination IP address. Okay. Now I am trying to tell about this local host address or loopback address. Every PC itself having one IP address. It is not configured to any NIC. Okay, it is configured to the PC only. Okay, at a TCP IP level. So every PC having a same IP address for itself only. For itself only, not to communicate outside. This is self-communicating. So this IP address we call it as a loopback or a local host address. For example, this PC name is DPCD or DPC, but itself a name is there called a local host. Itself name is a local host. Itself name is a local host. That local host IP address is 127.0.0.1. So what is the use of this local host? For self-testing purpose. Self-testing in 127.0.0.1 means to whom I am pinging? To myself only. To myself only. If I am pinging to 172.116.192.1, to who I am pinging? Some other device. It's not my PC. To some other device I am pinging. Okay, I'm not pinging to myself, I'm pinging to some other device IP address it is. But this is purely whether you are having an IP address or whatever the IP address you are having, but this is your local host address. You are pinging to yourself only. Where we use this one, not only for testing, also it is useful for so many places. For example, I installed some web application here. So some web interface is there. Or maybe I will give you an example. I install a Oracle database application. In this machine DPC, I install Oracle database application. It is a server application and I have a client application. Okay, this is the client application in this PC only. So I want to connect from this client application to my server application. I will try to connect with the 127.0.0.1 only. Because where is the server application and from where I am accessing? From same PC only. So I can use this one. For example, from BPC, I want to connect it to this server from VPC. From this client application, I use 10.0.0.14 only. So if I use 127.0.0.1 here, if I use this IP address here, I will connect it to VPC. From VPC, if I use 127.0.0.1, then I'm trying to connect it to VPC only. Okay, from VPC only. It's a loop back. Okay, but if I am trying to connect 10.0.0.14 means I am trying to connect to 14 dBs. That is the difference. Okay, so what is this loopback or localhost address? Every PC has its name is a localhost. The localhost IP address is 127.0.0.1. So if you are pinging to 127.0.1, it is a self-testing about knowing about TCP IP services running or not, working or not, like this. In case you are install some applications or a web related application or network related application, you want to communicate from your PC, you can use this 127.0.0.1. Okay. In IPv6, this localhost address is ::1. Okay, in localhost address you can see ping local host. I'm getting ::1 because of IPv6. -4 means localhost, both IP addresses are there. IPv4 address 127.0.0.1 and ::1. But I want IPv4 wise communication. That is localhost 127.0.0.1. I want to communicate with my IPv6 kind of communication. Then ::1. Okay, so that is the difference. Okay, localhost address is in IPv4 127.0.0.1, whereas IPv6 is ::1. And we have an unknown IP address kind of concept is there, that is called 0.0.0.0. Like we use it for certain process and default routing process. 0.0.0 like this is in IPv6 it is a ::1 only. Okay, in IPv6 it is ::1 only. Of course, there are some more points for IPv4 and IPv6. Okay. Here in IPv4 we have a unicast, multicast, and broadcast type of IP addresses, whereas in IPv6 you have unicast, multicast, and any cast of IP addresses are there. And in IPv6, because we are not discussing more about IPv6, that's why I'm giving these details also. In IPv6, generally I'm not getting any IPv6 IP address to my PC, but I will show some IP address. This is global unicast. If you see any IPv6 address starting with 2000 kind of stuff, mostly it is global unicast IP address, 2000 to 3000. It should not say 2000 to 3000 kind of stuff, but for our understanding, anything start with a 2 or a 3 in a first block, it is a global unicast type of IP address. You got an IP address from router, like you are using Jio or Airtel, then in case you receive an IP address, you check an IP address, it is showing IPv6 address as 2450 something like that. It is a global unicast address. It's like a public IP address. And private IP addresses are there, and multicast IP address ranges are there, but mostly useful this is link local. What is this link local? I will show you. Every NIC configured with one link local IP address. You can see link local IP address. If you see your First, like this. FE80 : means it is a link local IP address. You see any IPv6 address with FE80 means it is a link local IP address. Any NIC which is IPv6 is enabled inside, automatically you can see link local IP address. I will show here also. See, this is also having a link local IP address. This link local IP address generated from your MAC address only. This NIC's MAC address only. Based on this MAC address, it is generated. It is valid. Within the LAN, we can able to communicate with this. Okay, if you go to IPv6 part here, I am unchecking IPv6, means I'm disabling IPv6. Okay. Then again I open details. See where is that link local IPv6 address? Gone. Why it is gone? Because of IPv6 protocol is disabled here. If I enable again, I'm not giving any IP address. See, it is, I didn't give any IP address, or even I don't have any particular DHCP server to give IP address, IPv6 address. But you can see link local IP address. FE80 : means it's a link local IP address. Of course, we can communicate with this IP address to other PCs. This is an explanation for that loopback address kind of stuff. Yeah. So it is from till now I use very slow, but now I think it is faster again. I will make it little slower now. So look at here, guys. I am talking only IPv4. Once again, please listen. And again, IP address. What is an IP address? What is IP address and MAC address? Please compulsory go through it. Okay. I'm talking only IPv4 now. IPv4 is 32-bit, 2 to the power of 32, 4.3 billion IP addresses. IPv4 format is look like this one. The numbers are decimal numbers only. Okay. So this 32-bit total IP address is divided into 4 parts separated with a dot. Okay, 4 part means 8 bit for each part. The part we call it as an octet. The octet size is 0 to 255. Either 0, 1, 2, 3 up to 255 it is there. So each part we call it as octet. The first one we call it as the first octet, second one we call it second octet, third one we call it third octet, fourth one we call it as a fourth octet. And also WXYZ we are telling. Okay. So each octet range is up to 0 to 255. Okay, up to 0 to 255. Okay. Understand that point, guys, at least this point, IPv4 point. What is octet means? What is 32-bit? Up to here and understand? Okay. So these total IP addresses, if you see, these are the total range of IP addresses 0 to 255 means 0.0.0.0 to 255.255.255.255. So this is total IP addresses. These are the total IP addresses. These are the total IP addresses. This entire total IP addresses divided into 5 classes. From this entire range is divided into 5 classes. Class A, Class B, Class C, and Class D, and Class E. Okay. So in this one, depends upon the first octet. Means if you see as a IP address like a WXYZ, W part, first part of IP address, first octet. So we can say if you got an IP address, if you want to tell which class it is, you have to tell which class it is. Okay, which class it is. Then okay, so how to tell depends upon these ranges. Okay, so the class A range is 0 to 127, class B range is 128 to 191, 192 to 223, class C, class D 224 to 239, class E 240 to 255. Class A is this complete range is reserved for a future purpose or research and some certain places only. We don't use in general communication. In multicasting address is class D is a multicasting range. If you see any IP address with 124 or more than 124 means 124 to 139, anything first octet of IP address having, that is a multicast address. Again guys, in our communication we don't use multicasting here. Okay, we cannot assign. We use multicast IP addresses, but we cannot assign to any adapter. Multicast IP addresses use it for a specific purposes, a specific range, okay, specific protocols like a EIGRP, RIP version 2, OSPF. They are communicating each other through multicasting only. They will share information through multicasting IP addresses. Means unicast and multicast. These three are a unicast IP addresses and this is multicast IP address. So what is this unicast guys? If I send a message to someone, for example, here Arti is there, Rahul is there. For example, I send a message to Rahul directly. That is unicast. I want to send a message to all your people in a group. So I send a message in a group, a class at morning 10:30. So it is received to everyone, right? Everyone able to see the message. That is a multicasting. Okay, that is called a multicasting. Everyone in the group only, not everyone in my contact list, right? Everyone in the group, they do. So all are following same protocol. So means they will multicast. This multicast address is used by different type of protocols.
Sir,
So
sir,
yeah,
in IP like class A, B, and C, so are any there like speed differences? Like if I
no,
use a class A IP and B.
no speed. No, it does not affect on speed. Speed of network speed not affected with the whatever the class you use it. It is not depends upon your speed. Okay, good. Okay, again there is a IP addresses like a 0.0.0. We are not using this IP address. We cannot assign to any specific machine in the 0 series because these are the reserved IP addresses used for a certain services purpose. Like in certain places we use like a default routings or a DHCP services client purposes. Okay, so in certain process or certain protocols use this IP address 0.0.0.0 and also we don't use 0 dot series also. We cannot assign to any adapter. Okay, and of course we already discussed what is the loopback or localhost address. Okay, 127.0.0.1 it is also reserved for a loopback or a localhost address. So that is also we can't assign to any adapter. Entire 127 series we cannot assign to any adapter. Okay, that is a thing. So that's why if you search in a Google or some notes or textbooks, class A will shows as a 1 to 126 because of the 0 and 127 we are not using. But as per the range, So 0 to 127 is the actual range, but we don't use 0 series and 127 series. That's why in some textbooks it shows 1 to 126. Class B, Class C, 128 to 191, Class C, 192 to 223. Ranges by heart, guys. If you don't get these points, so please leave it, no problem, binary, but go to this ranges at least. Of course, already I told, if you check any IP address, if you see any IP address of any device, it is showing 169.254, it is occupied address, it meaning is error, you have to do troubleshooting. Here I have a certain list of IP addresses. Okay. First I will remove these things. So first of all, we'll try to guess what is the, which class it is. So 120, 9, 201. So you want to know which class it is. You want to guess what is the class of this IP address belongs to. Always look at the first octet and compare with this chart. 120 is in between 0 to 127. Which class it is? Which class it is? Class A. What is about this one? 151.
Class B.
Class B. However, 151 is in between this range. It means it is a class B. Always look at a first octet. 197. 197 is in between this range. It means it is a class C. 124, sorry, 224. 224, class D. Plus 240, class E. Of course, we don't use this one, but this is how we know. What are the things? See, it is 200 is there. Here 200 is there. Is 10 is there. It is 1 is there. Zeros are there. But whatever it is after second, third, fourth octets, what are the second and third, fourth octets? But you have to see the first octet first of all, and we can know and compare with that range list. We know what is the class of that IP address it is. Anyone guess this one? Which class it is? Class A, class B, class C?
Class C. Class C, sir.
Class A.
Class
A.
170.
Sir, it's class C.
B. Class B, sir. Class B.
Okay, 170. Class B. Okay, because we, whenever you seen it, I know why you said as C, because when you see 192, then it is attracting 192 and it is become C. Okay, now first see the first octet and compare with this range, then we'll know it. Okay, so this is how to know which class of this IP address. When you see an IP address, we'll know it. Okay, guys, understand this list?
Yes, sir.
Now, just only 1 minute. Why I'm going outside? Because I'm going to tell again. So that's why. Meanwhile, I will tell one link. Type in your Google in interview questions. Interview questions. Vishnu Prasad already came. If you type in Google interview questions, Vishnu Prasad. So I select all. This is the Google site. Okay, this is the Google site. Okay, so there is a lot of menu is there, but I am telling in a home page only. In this page only, lot of questions. Okay, so take each and every question, mainly small questions, not big answered questions. Okay, so what is operating system, type of operating system, type of servers, what is VPN, what is this thing. Okay, so this is the very big one. It will waste your time and you don't understand, then leave it side. Okay, see here it is, difference between NT 2000 2003, very old. It is useful but not now, so don't waste the time in the very big answers. Put the time on your things. What is Active Directory? Okay, which the word you use, what words we are well known part, then you can try it. Difference between DC and ADC, OU. Okay. I will go directly this networking part. See, it is IP addresses, their ranges. Okay, IP addresses, their ranges. See what is hardware router, software router, firewall, software firewalls. Okay, direct network based questions also there. You can go to network based questions. This is a unknown part, but see, network is started here. Go to network, see what is peer to peer, what is client to server, what is LAN, what is MAN, what is NIC, what is MAC address, somewhere it will be there. Different type of cables. Okay, different type of cables, different topologies. Okay, different technologies we are connecting. What is hubs, switches, routers, gateways, repeaters, IP addresses, NAT, PAT. Okay, so OSA layers. So it is very easy, right? So put it in your mobile phone, then you can keep reading it. Which if you don't understand something, like you don't understand what is ISDN, so leave it, no problem. If you never hear about it, leave it, no problem. But what you know, that required information, that is what you know, you must tell strongly. What you don't know, that is secondary part. That is you will learn later. But what you know, make sure thoroughly you are with that one. For example, I said I know this printer configuration. I can tell about it step by step, step by step. So that is why these are the okay. So that's the point. Again, there's a few more points about your IP addresses. Normally, for any classes, I will type into the notepad, but now, okay, guys, see, this is first three classes only we are using because of it is unicast. Okay, so this is a class A, range is 0 to 127, 128 to 191 is a class B, 192 to 223 is a class C type. Okay, why we are dividing this into the classes? One is in the world, earlier days very less computer, but now number of devices are higher. In myself, I have a laptop, mobile phone, and tablet, and Kindle is there. One desktop is there. So I need a 4 or 5 IP addresses. That is difficult to manage from 3.4, 4.3 billion IP addresses are not enough. Okay, not enough. So what I will do? So what we will do? So yeah, okay. So we divide the ranges into network and host wise. If you see, if you use a class C type of network, Okay, then you can connect maximum of 254 devices in a single network. Okay, if you use class B network, you can connect more than 65,000 devices, means 65,534 devices you can connect in the single network. If you are using a class A, then you can connect more than 16 millions of devices we can able to connect, means 16 lakhs devices we can able, no, not 16 million. As a 16 million it is, but lakhs wise it is 61 crore 67 lakhs devices we can able to connect it, or a 16 million devices we can able to connect it. Okay, next. Okay, so how it is possible, guys? If you are using class C in IP address, the first three portions are a network portions, and I didn't take in this thing, so I will add this information here. So these things, remember the rules in a communication, guys, in a communication in a LAN. Okay, the first rule is devices must be in the same physical network, of course, but very important is they must be in the same logical network also. Okay, because IP address is a logical address, it will define a logical network. So if you have a two devices or two or more devices, you want to make a communication, their network ID must be same. Or we can say their network portion must be same. Okay, we can say their network portion, the devices network portion must be same, or we can say their network ID must be same. Okay, I have three IP addresses. This is the class C. Okay, this class C first three portions are network portions. So this is the network portion and this is the host portion. Host portion in the sense, see guys, the number sequences. For example, pin numbers, roll numbers. For example, here belongs to batch 9, right? So I put a N9, your roll number as a 1. So 901, 902, 903, 904, 408. Meaning is these are all ninth batch. This is fourth batch. But this sequence is changing, right? This numbering is different. But this part is telling which batch number. Okay. Same way in the network portion will tell there all belongs to same network. Okay. Host portion is telling the host number. That's why it is telling uniquely identify a device, not unique identification. It is uniquely identify a device in the network is the IP address. Okay. So this is network portion. This is host portion. Class B, first two portions are network portions, second two portions are host portions. So this is a network portion, first two portions are a network portion, and remaining is host portion. It means if you are using this IP address, two or three machines, their machine, the first portion, these two must be same. So I will give you an example here. You can see this is class B IP address. Class B IP address, first two portions are a network portion. I have a PC1, PC2, PC3, PC4. I configured these IP addresses to each and every PC. Okay. What happened? PC1 to PC2. See, 127, 127, 127, 127. First portion is same. But network portions are two, right? First portion and second portion both are network portion for class B IP address. Here is a 16, 16, 16, but it is 17. What are the remaining thing? Third portion and fourth portion, no problem. Important is network portion must be same, but here the network portion is different. So PC1, PC2, PC3 will communicate each other. PC4 is not communicating each other. Okay. You may get a doubt. I have a one kind of network. I have a network, but outside different networks are there, right? So in a different places like a google.com different network, yahoo.com different network, you are in the different network. How we can able to communicate? Okay, because you are in the different networks, separate networks. So we have to use a router. Router is a inter-networking device. Router makes a communication between these different logical networks. Okay, so these are the rules, guys. You want to communicate in the network, you must be in the same network portion. So these are some examples. Okay, so if you see APC, BPC is a class A IP address, ABC are a IP addresses are there. If you check okay, so first portion is same for A and B, they will communicate each other, but first portion is different, so they will won't communicate. It is a class A IP address. In class A, first portion is network portion, remaining is host portion. So first portion only we have to check it, make sure they were same. See, it is second portion is different, no problem, because it is a host portion, no problem it is. Last point I will tell. So but this is the last point. Two more points are there. In this sequence, this is actually last point is what is the subnet mask? What is subnet mask? Subnet mask will tell your network address, network ID. See, it is whenever you have an IP address, there is a subnet mask. This subnet mask tells what is your network ID. What is your network ID? If both the machines are in the same network, they will communicate each other directly. Okay. Subnet mask divide IP address into network portion and host portion. So using subnet mask, we know what is the network portion and the host portion. Using subnet mask, you will get a network ID. See, this is the IP address. This is subnet mask. I convert both of them into both into binary and done AND operation. AND is a logical gate operation. If you don't know what is AND gate or logical gates, not at all a problem at present. Okay. In the future, if you want to learn complete networking, so then you can try these things. Okay. So what is the AND gate? See, if both inputs are 1, output is 1. One input is 0, any one input is 0, output is 0 only. That is the AND gate logic. See, 1, 1, and I got a 1, 1, 1, I got a 1, 0, 1, I am getting 0. Same thing. 1, 1, 1, 0, 1, 0, 1, 1, 1. Here it is 1, 0, 0, 1, 0, 0, 0, 0, 0. It is like that. It will calculate, find their network ID. Both the systems network ID is same. They will communicate each other. These are the default subnet masks for class A, class B, class C. Okay. So if you see, this is not a 255. This is the class B IP address. Originally 255.255.0.0 should be there. Okay. But why it is not there like that? So this is a class B 255.255.0.0, but it is not showing like that. Why it is? That is a not a default subnet mask. It is changed subnet mask. Changed subnet mask. So this is a subnet mask. Same subnet mask we can represent in a slash notation. Okay. So what is the subnet mask? You will write a subnet mask in like this 255.255.255 kind of stuff. But also you can tell a subnet mask in the names like a prefix kind of stuff. Okay. See, this is a IP address and this is the subnet mask. You can also say you can give an IP address like this is IP address and subnet mask, or you can say like this subnet your IP address /24 means 24 ones are there. So 255 means 8 ones in binary. Okay, so totally it is 24 ones in here. So that is why it is represented like this. If you don't tell your subnet mask means this is classful, means subnet mask is default only. Okay, this is some IP address and here it is I given certain subnet mask because compulsory you have to tell a subnet mask if in case subnet mask is different than a default one. So yeah, leave it all these things guys. You can write a subnet mask like this, or you can write a subnet mask like a slash notation. This method we call it as a CRDR method, or we can also call this one as a prefix. The prefix or a slash notation represents a subnet mask. Okay, like this. So these are the default subnet masks /8, /16, /24. If you put /25 means this is a subnet mask. Okay. So this is about your IP address and subnet mask guys. To communicate in the network, we need an IP address. To communicate within the network, compulsory, those IP addresses must be in the same network ID, same network they have to follow. How we know both are in the same network? Their network portion must be same or their network ID must be same. How systems understand both the systems are having same network ID, it is based on their subnet mask. It's based on their subnet mask. Okay. So subnet mask do the AND operation, find out what is network ID. Okay. If both network ID matches, they will communicate each other. If different networks are there, so definitely they won't communicate each other. Any which ways as a part of IP address guys. So small point I will add it. So 2 points are there actually. In IP addresses, while you are communicating in the network, okay, so you know there is a private IP addresses and there is a public IP addresses. So you are in your own LAN communication, your private network it is. So means no direct internet connection. Internet is we are connecting through router modem, then we are connecting to internet, but internally it is a private network only. Okay, either it is no internet private network kind of stuff, or it is your LAN you are connecting to public. So within your LAN, within your private, you can use you don't require any permissions or you need to buy any IP addresses. Okay, you can no need to buy any IP address. It is non-routable IP addresses, means with this IP addresses you cannot communicate in the public directly. Like I have a private IP address. With this IP address, I cannot communicate public directly. So you cannot send a packet to my private IP address directly. Okay. So that is these ranges. Class A, Class B, Class C ranges, and out of that is a Class A is a 10 series, 10.0.0.0 to 10.255.255.255. It is a single network. Class A giving only one single network, that is 10 series. Okay. Class B is a multiple networks are there. So 170.16.0.0 to 170.31.255.255 means 170.16, 170.17, 170.18, 170.19, like up to 170.31 networks are there in the class B. In class C, 192.168.0.0 to 192.168.255.255. This is the complete range. And totally 256 networks we are getting in a class C for a private. In a private. So these are the private IP addresses. Anyone use these private IP addresses in their private network, in their LAN communication. Okay. Guys, we are all getting internet, even though I am having a private IP address, but I am getting internet, I can communicate in the internet because of this NAT and PAT techniques, network address translation, port address translation. Okay, this network address translation maps internal IP to external IP kind of stuff. Okay, so you have your own private IP address, but your router translate into the public IP and send your packet. Means while you are communicating in the public, you communicate with public IP address. Internally use your own private IP address. But who will map this one? Your router or your modem, your ISP will take care of that one. This is called a NAT technique. But problem is here. Problem is there. What is the problem? What is the problem? So you have a 10 private IP addresses. You need a 10 public IP address. Public IP addresses are very limited and it is very costly. So in our daily broadband connections, we use PAT technique actually. It is a NAT technique only, but it is NAT overload technique. You have a multiple IP addresses. You have a multiple private IP addresses. We can load it on a one single public IP. So 10 private IP, one public, or 20 private, one public. It is NAT overload. It uses a port mapping technique to do this mapping. Of course, you can send a packet and you receive a packet based on your sending. Means you send a request, you open a google.com, you receive a google.com packet. You open a facebook.com, the facebook.com server will give you a packet, means information. But directly facebook.com want to send a packet to you directly with your private or public IP address, it cannot send because of PAT technique. Okay, so this is your network. So today I think a lot of people listen, but they forget what they listen. Okay, the last guys, very simple. What is a IP address? Difference between, remember these things, compulsory read. What is IP address? What is the difference between IP and MAC address? IP address versions, IPv4, IPv6, basic differences, not required all differences, very basic differences important. In IPv4, important is the classes and their ranges and subnet mask, default subnet mask is important. And what is the use of subnet mask? That's it. I told big story for more than 1 hour, maybe 1 hour, but very important is what is an IP address, difference between IP address and MAC address, IPv4, IPv6 differences, basic differences are important. And next one is IPv4 classes is important, classes and their ranges. Okay. Next, default subnet mask and what is the use of subnet mask. Okay, and of course what is the default gateway, that is in networking also default gateway is also important. Next, OSA layers, TCP IP layers, networking devices and what is the difference between those devices. Okay, devices differences, hub, switches, router, modem differences are important. Use of modem is important. And next, different topologies, LAN WAN differences, LAN WAN differences, LAN WAN CAN WAN is there now. So those differences. What is network? What is networking? What is internet? What is intranet? These are the important things. Okay. So compulsory, go through once again. So be confident in it. That's it. Anyone, anything want to say? Like your final words. Tomorrow class is there. Okay. లేదు సార్ నాది 1:30 యాక్చువల్లీ వచ్చేస్తాను అయిపోయింది క్లోజ్ రికార్డింగ్ స్టాప్ చేసి